All right, so we want to continue our class from where we stopped yesterday. So let's look at this example. A rabbit runs across a parking lot. A rabbit runs across a parking lot on which a set of coordinate axes has been drawn. The coordinates in meters of the rabbit position as function of time in seconds are given as follows. We have the position vector. That is a 2D vector. We have x equals minus 0.31 t squared plus 7.2 t plus 28. Y is equal to 0.22 t squared minus 9.1 t plus 30. A, at t equals 15 seconds, what is a rabbit's position vector? In unit vector notation and in magnitude angle notation. B, find the velocity at time t equals 15 seconds. And C, find the acceleration at time t equals 15 seconds. So we start with A. In A, we are asked to find the position vector in unit vector notation and in magnitude angle notation. So remember, when you are asked to find position vector in unit vector notation, what the question is asking you to do is find the position, that is the displacement, and then represent your answer in component form, that is IJK. IJK form. But now, in this case, it is going to be IJ only because we have only X and Y coordinates. There is no Z coordinate. So X will give I, Y will give J. So now, so our X, which is a position vector, X, we have minus 0.3T, 331 T squared. So, but T is given to us as 15 seconds, which means wherever we see a T, we substitute 15. That implies that our X, let me write it here, our X will be equal to minus 0.31, 15, T is 15, square, T is square there, plus 7.2 T, T is 15, plus 28, plus 28. So now 15 square times minus 0.31 plus 7.2 times 15 plus 28 will give us 66, 66 meters. And then that is for X. For Y, we have 0.22 t square, which is 15 square, plus, sorry, that is a minus 9.1 t, which is 15, plus 30. So if you simplify this, it will give you minus 57 meters. So our position vector, which is r equals xi plus yj. These are position vector for 2 dimensions. If it is 3 dimensions, it will be plus zk. But here we are given 2 dimensions. So this will now be r equals 66 meters, or 66i, plus, okay, here we have minus 57, so that will be minus 57j, all in meters. So 66i minus 57j in meters. That is our position vector in unit vector notation. Now we are asked to find also the what is the rabbit position vector in unit vector notation. So that is what we have done. Now we are also asked to find the magnitude and the angle. The magnitude and the angle. Recall, to find your magnitude, which is written as this, is equal to square root of x squared plus y squared. Square root of x squared plus y squared. So that if we substitute the value, that will be square root of 66 squared plus 57 squared. So that will give us 88 or 87 meters. So the magnitude is 87 meters. Now we are also asked to find the angle. The angle. The angle. To find the angle, we use tan theta. Remember that this is y and x component. So it will be like this. This is x component. This is y component. So so theta tan theta will be equal to opposite over adjacent. That is y over x. What is y? Y is minus 57. What is x? X is 66.
66.
Yeah, so if you simplify this, find theta. Theta will be tan, second function tan, minus 57 over 66. So that will give you minus 41 degree. So the angle between them is a minus 41 degree. So that is A. We have just solved only A. What is the rabbit's position? Vector in unit vector notation. We got that as 66I minus 57J, all in meters. Then what is the magnitude? The magnitude is 87 meters. And what is the angle? The angle is minus 41 degree. So let's move to B. B is find the velocity at time t equals 15. Now, this kind of question has to do with, the way to solve this is to apply instantaneous velocity, because the question is asking you the velocity at a particular time. So whenever you are asked to find velocity or speed or acceleration at a specific time, it has to do with instantaneous. So this is instantaneous velocity problem. So in that case, V is equal to dx over dy. So this is Vx. Vx is equal to dx over dy. Then Vy subscript y is equal to dy over dt. Sorry, it's not, it's dt. Dx over dt and dy over dt. So we are going to solve for Vx. So if we differentiate x with respect to t, differentiate x with respect to t, that will give us Vx to be minus this. If you look here, you see that t here is raised to power 2. So the 2 at the top, that is this superscript, will multiply this value, 0.31. So we have 2 times 0.31, that will be 0.62 t plus 7.2. So that is our Vx. Now, remember that the question says at t equals 15 seconds. So it means that we are going to substitute for t as 15 seconds. So that will give us minus 0.62 into 15 plus 7.2 plus 7.2. So that will give us minus 2.1 meter per second. Minus 2.1 meter per second. That is our Vx. Now, our Vy will be to differentiate y with respect to t. So that will give us 0.22 times 2, 0.44, 0.44 minus 0.44 t minus 9.1. So this will give us, if we substitute t as 15, it will give us minus 2.5 meter per second. Minus 2.5 meter per second. So in terms of unit vector notation, our v will be equal to v of x, I, plus v of y, j. So that will translate to v is equal to minus 21 minus 2.5, 21i minus 2.5j, all in meter per second. Meter per second. So if we want to find the magnitude, V magnitude will be square root of Vx square plus Vy square. So that is square root of 2.1 square plus 2.5 square. So that gives 3.3 meter per second. So this is the magnitude of V. And then if we want to find the angle at which the velocity of the S component, the angle between the velocity of the S component and Y component, that will be theta is equal to second function of tan V of Y over V of X. V of Y over V of X. So V of Y is minus 25, minus 2.5. V of X is minus 2.1. So the minus will cancel out. We are going to have second function of tan 2.5 over 2.1. So that will give us minus 130 degrees. So theta is equal to minus 130 degrees. Now the third question says, find the acceleration at time t equals 15. So to find acceleration, it means that we are going to differentiate one more time. Remember that acceleration A is equal to dv over dt. Dv over dt. So we are going to have ax to be dvx over dt, and ay will be dvy over dt. So what is ax? Ax will be, remember that the Vx is equal to minus 0.62 t plus 7.2. So Ax will be 0.62. 0.62. Ay will be, from our previous work in finding velocity of y component, we have Vy to be 0.44 t minus 9.1. So Ay will be 0.44. So Ax will be 0.62i, Ay will be 0.44j. So if we want to find the magnitude and direction for A, A will be square root of Ax plus Ay, which is square root of 0.62 square plus 0.44 square. So that will give us 0.76 meter per second square. Zero point 0.76 meter per second square. That is the magnitude of A. And then the angle of the acceleration will be second function tan Ay over Ax. Ay over Ax. Ay, which is 0.44, divided by 0.62. 0.62, second function of that. So theta A will give us minus 35 degrees. If we want to convert it to positive, we add 180 to it. So minus 35 plus 180 will give us 145 degree. So the acceleration of the rabbit is, okay, the angle between the x component and y component of the acceleration of the rabbit is 145 degree. So that is how to solve this kind of problem. So here we have another exercise. The question says, a train changes its position. Yes. A train changes its position, x, as a function of time, as follows. X is equal to 10 plus 3t squared. X is measured in meters. A, find the displacement of the train between t equals 1 second and t equals 3 seconds. Find the average velocity during the same time interval, that is t1 equals 1 second and t2 equals 3 seconds. C, find the instantaneous velocity at t equals 3 seconds. And D, find the acceleration of the train. So the first question A says, find the displacement. Remember, displacement is change in position of an object. So if we define displacement as change in position, so this is S component, that will be X final minus X initial. In this case, X final is equal to X2 when time is 2, and X initial is when X is 1. So let's substitute to get what X1 is. So X2 means we are going to substitute time 2, which is 3 seconds, into this X equation. Wherever we have a T, we replace it with 3. So which implies that X2 will be equal to 10 plus 3. T is 3. 3 and it's a square. So 3 square. So this will give us 3 square is 9. 9 times 3 is 27. 27 plus 10 will give us 37 meters. That is X2. So what will be X1? X1 will be when T is equal to 1. So that is 10 plus 3, t is 1, so you put 1 square, then you simplify. 1 square is 1, 1 times 3 is 3, 3 plus 10 is 13. 13, so x1 is 13 meters. So now change in position, which is displacement, will be x2 minus x1. x2 is 37, x1 is 13. So displacement will be 24 meters. So that is answer to our A, 24 meters. Now, B says find the average velocity during the same interval. Average velocity during the same interval. What is average velocity? Average velocity is change in position over change in time. So average velocity is equal to change in position over change in time. What is change in position? That is displacement, is 24. And what is change in time? T, change in time is T2 minus T1. T2 is 3, T1 is 1, that is 2. So change in time is 2. 24 divided by 2 is 12 meter per second. So that is our average velocity. Now, C, for C, we are asked to find the instantaneous velocity. That is the velocity at a specific time. So the velocity at a specific time will be V is equal to dx over dt. So if we differentiate this expression, we are going to have 2 times 3, that will be 6t. But t is equal to 3 as we are given. So we substitute that, that will be 6 times 3. So that is 18 meter per second. So that is our instantaneous velocity. And finally, D, we are asked to find the acceleration of the train. Acceleration of the train. So A is equal to the V over the T. The V over the T. So we differentiate this. Differentiate V, which is 6T. V is equal to 6T. So if we differentiate it with respect to T, A becomes 6 meter per second square. A becomes 6 meters per second square. So that is our acceleration. So that is all for this exercise. So let's look at another one. So here we are given the position of a projectile traveling in 2D space is given by x of t equals 2t squared plus 4t plus 3 meters, and y of t is equal to 3t squared minus 5t plus 2 meters. Calculate the magnitude and direction of the projectile displacement and the average velocity between time interval t equals 2 seconds and t equals 5 seconds. So now to solve this, the first part of the question says displacement. Now, not just displacement, but magnitude and direction of the projectile displacement. So when you hear the word displacement, the first thing that should come to your mind is change in position, which is x of 2 x of 2 minus x of 1. So what is x of 2? The displacement at time 2, and time 2 is 5 seconds. So this will be x of 2 is equal to 2 into 5 square plus 4 into 5 plus 3. So that will give us 5 square is 25. 25 times 2 is 50. 50. 4 times 5 is 20, and plus 3. So our answer will be 73 meters. So that is our x2. x2 is 73 meters. So what is our x1? x1 will be at t equals 1, that is 2. So 2 into t squared, t is 2 this time. So 2 square plus 4t. T is 2 plus 3. 2 square is 4. 4 times 2 is 8 plus 4 times 2, 8 plus 3. That is 19. 19. So displacement will be 73 minus 19. So that is 54 meters. X is 54 meters. And let's look at displacement along the y-axis. So displacement of y what is y2? y2 will be equal to 3 of 5 square minus minus 5 of 5 plus 2. This is 75. 5 squared is 25. 25 times 3. 75 minus 25 plus 2. So that is 52 meters. So y2 is 52 meters. So what about y1? Y1 will be 3, 2 square minus 5, 2 plus 2. So 2 square is 4. 4 times 3 is 12. 5 times 2 is 10 plus 2. So that is 0. So y1 is 0, which simply means that initial position of y is at the origin. So change in y will be 52 minus 0. That is 52 meters. 52 meters. So we are asked to calculate the magnitude and direction. So what will be the magnitude? The magnitude will be x squared plus y squared, which is equal to x is 54 squared plus y is 52 squared. X is so um so 54 square is 2916 and 52 square is 2704. So if we add them together, That is 5620. Find the square root of that value. 5620. So the magnitude is 5620. Square root of 5620. So that is 70, approximately 75. Approximately 75 is the magnitude. Now the direction, which is angle, that will be theta equals to tan theta equals tan second function y over x. What is y? Y is 52 over 54. 52 over 54. So that is 40, approximately 43.9, 43.9 degree. (43.9 degree). So that is the magnitude and direction of the projectile's displacement. Now, we are also asked to find the average velocity between the same time interval. Average velocity. Remember that average velocity, V average, is equal to change in position over change in time. Change in position over change in time. X is 54. Difference in time is between 5 minus 2, that is 3. And for this is X. For Y, we have 52 over 3. So 54 over 3 gives 18 meter per second, and then 52 over 18, 52 over 3 is 17.3. 17.3 meter per second. (17.3 meter per second). So that is average velocity of X component and Y component. Now we are asked to find the magnitude and direction of that. So in that case, to find the magnitude, we'll have square root of 18 square plus 17.3 square. (17.3 square is 300, while 18 square is 324. So if we add them together, that is 624. The square root of 624 is 24.9, 24.97. So the magnitude of the average velocity is 24.97 meter per second. 24.97 meter per second. And then the direction will be 17.3 divided by 18. 17 point theta is equal to second function of time, tan 17.3 over 18. That is 0.96. 0.96. Second function of that is also 43.9. So degree. So the angle between the direction of the displacement of the projectile displacement is the same as the direction of the projectile's average velocity. So that is how to solve problems such as this. So now, motion at constant acceleration. Godwin, there are 4 basic equations of motion that you need to know. Which are these? V is equal to V for final velocity is equal to the initial velocity. This is 1. This is 1. This is 2. This is 3. And this is 4. These are the 4 equations of motion that you need to know. So in the first equation of motion, you have V. V is the final velocity. You have V subscript 0, or you can take it as V is equal to U plus AT. That is the first equation, where V is the final velocity, U is initial velocity, A is acceleration, and T is time. T is time. Now, the second equation, for the second equation, we have x is equal to x naught plus, so let me rewrite this in the way that you know in your O level. So this is mostly written as x is equal to xi plus ut plus half at squared. In your secondary school, most times you discover that this first one is not there. So the equation now appear to be S is equal to ut plus half at squared. The equation is still the same. Now, the difference between these two equations is that for this, it is assumed that the object is starting from rest. That is, rest means the initial position Si is equal to 0. So if you substitute Xi equals to 0 into this equation here, this equation becomes this. The second equation will appear to be this. But if the object is starting at a particular position, then it will take the form of this. Now, let me use a graph to explain what I just said. Now, if I have a graph like this that starts from the origin, then I will say that this equation, that is distance time graph that starts at origin. This is S equals ut plus half at squared. However, if the graph is something like this, that is, there is an initial position. The graph is not starting from the origin. So with that, you have to include the initial position xi plus ut plus half at squared. So the equation will take this form. So note that the difference between the two equations. Now the third equation is also similar to the second equation, in that the initial position and the final position is considered. And this will bring us back to displacement, which is x. X is equal to change in position. Remember that x is equal to change in position, in final position minus initial position. So see this in bracket as that final position minus initial position. So if I change this to v square is equal to u square plus 2a, I can write change in x. So it is still the same. That is displacement. Then finally, the fourth equation is average velocity, which is V is equal to sum of the velocity divided by 2. If I have x1, x2, x3, x4, and I'm asked to find the average of these four numbers, it will be x1 plus x2 plus x3 plus x4 over 4. That is the average. So this time, I have just two, final and initial. So I can write that the final V plus U over 2 will give me average velocity. So that's another way of getting your average velocity. So with this, you should be able to solve problems related to equation of motion. Now, free fall. This equation of motion as it is basically can be used to solve both, that is one-dimensional motion, motion in one dimension, that is horizontal motion or vertical motion. So if it is horizontal motion, we are applying this equation to solve. As it is, we just use it the way it is. But if we are going to apply this equation to vertical motion, that is object falling from a height, we will do little alteration, and that is all A will be changed to G, acceleration due to gravity. And of course, if the object is falling down, it is moving towards the earth, that is in the direction of the gravitational pull, that would be positive. But if the object is going up, G will be negative. G is positive if the object is coming down, and G is negative if the object is moving up or going up. And then we can also replace all our X to be Y or H. Our X, remember that X is horizontal, Y is vertical. So we can represent X in the equation as Y or H. So those are the alterations that we need to know about before we apply it to solve vertical problems. So let's go on to free fall before we call it a day today. Free fall. Near the Earth's surface, all objects experience approximately the same acceleration due to gravity, that is G. Acceleration due to gravity is constant for all objects near the Earth. Important points that you need to know. In free fall, there is no air resistance. Air resistance is not considered, is neglected or is ignored. So A is equal to G, and I've explained that why A is equal to G, because the object is pulled by or affected by the gravitational force or attraction of the Earth. And it has a constant value of 9.8 meters per second. Now, if the object is going up, the acceleration to the gravity is negative. If it is coming down, is positive. When an object is dropped from a height, the initial velocity is always zero, because if I drop an object from a height, I don't need to throw it. On its own, it will fall down freely. So initial velocity is always zero. And when an object is thrown upward, at the maximum height, before the objects turn around and begin to come down, it will experience a moment of rest. So at that point, you attain a final velocity, and that velocity, which is the final velocity, is always equal to zero. The velocity at which an object is thrown upward is positive. And then the velocity at which an object is thrown up, an object thrown up comes back, is negative. So if I throw an object up and it's positive, when the object is returning, coming back, falling down, it will be negative, because velocity is a vector quantity. Since it's a vector quantity, upward motion and downward motion will not have the same sign. If I consider upward motion as positive, the downward motion will be negative. Now, the time it takes an object thrown to get to the topmost will also be equal to the time the object will take to return to the position from where the object was thrown. So these are important points that you need to know when solving problems related to free fall. So like I said before, the equation of motion can be applied to vertical motion. However, when you want to do that, you have to change some of the parameters. Like A is changed to G, X is changed to Y. So this is where we'll call it a day. I've sent the slide to
Okay, sir.
your class captain. There are some solved examples there. Just play around with it. When we meet next week, we'll continue from there.
Thank you so much, sir.
All right.